So this is the first question. It is related to logic gates. Some electric circuit is given, two switches A and B are given. So you need to identify which gate is represented by this circuit. It can be drawn like this, corresponding circuit. Here 5-volt battery is connected. Here some resistor R is there. It is missing in this. Actually these questions are based on memory based of the students. There may be some mistake. So here it is having a bulb. We can assume S1 as A, S2 as B, and C is bulb. When current is flowing through the bulb, it is to be taken as 1. Usually if nothing is mentioned, when switch is closed, that state is considered as 1. When switch is in open state, that state is considered as 0. If anything is mentioned, we can consider those states. Otherwise, it should be taken like that. Now, let us assume A0, B0 means both the switches S1, S2 are open. When both the switches are in open state, current flows through the bulb, means it lights. Then we can give state 1 to bulb. When S1 is open, S2 is closed, means it is 0, it is 1. There is no way of current to flow through this as it is in open condition. Again current flows through the bulb, so C will be 1. Similarly, when A is 1, B is 0, we will get 1 here. When both are 1 means when both the switches are closed, there is a short path, means bulb is just short circuited through both the switches, so current flows across this path. There will be no current through the bulb. In this case, it is represented with state 0. So it is clear this logic truth table is corresponding to the NAND gate. So option 1 is correct here. Let us go to the second question. Choose the correct option based on the column shown below. Actually it is matching. Something is missing here. Some range should be there. But according to the given information we can identify. First of all, we can look at the frequency, means FM radio station consists of bandwidth of 88 megahertz to 108 megahertz. So clearly it is belonging to this. And if you look at the satellite, usually it is operated at high frequencies. This communication is belonging to large frequencies, so it will be 12 gigahertz. And TV signals usually at 30 megahertz. So remaining amplitude modulated wave may consist 1 megahertz of bandwidth around. So if you match this, we will get, first of all, for TV signal Q should be there. We are having only one option in which Q is there for 1. So option B. Let's go to the third question. Two vectors P and Q are perpendicular to each other, then find the value of M. So here it is given vector P equal to I cap plus 2M J cap plus M K cap, and vector Q is given as 4 I cap minus 2 J cap plus M K cap. If they are perpendicular to each other, P dot Q equal to 0, simply dot product of this gives 4 minus 4M plus M square. 4 minus 4M plus M square equal to 0. Solving it for M. So by using minus B plus R minus form, it is 4 plus R minus square root of 16 minus 16 whole by 2. So which comes out to be 2. So here it is given with option B. Next question. In an electromagnetic wave, electric field and magnetic field is given by E equal to E naught sin kx minus omega t plus pi, B equal to B naught sin kx minus omega t plus pi. Find correct relation. We know that in an electromagnetic wave, electric and magnetic fields are related as E naught equal to B naught c if wave is propagating in free space or air. If it is propagating in a medium, then it can be written as E naught equal to B naught into V, where V is velocity of wave. V can be written as omega by k. From this it is clear E naught by B naught equal to omega by k, which is given with option A. Next, fifth question. For an isothermal expansion, an ideal gas is closed in a closed container at different temperature. PV graphs is given. Then choose the correct graph where T1 greater than T2, T2 greater than T3, T3 greater than T4. Usually for isothermal process, we get the graph like this. We know that it is a rectangular hyperbola on PV diagram. It should be like this. At any point, as temperature is constant, product of P and V should be proportional to temperature according to the ideal gas equation PV equal to nRT. From this it is clear, if temperature is large, this curve will be far away from the origin of the PV diagram. So according to that, we can eliminate B and D options as it is given straight lines. We have to look at A and C options. In A and C, T1 is larger than T2 means T1 should be farther away from the origin. So this is the correct representation of the required PV diagrams for isothermal process. Next, question number 6. Two statements are given here. Steel is used in construction of bridge and house. Modulus of elasticity of steel is high. Usually elastic modulus of steel is high, bulk modulus, Young's modulus, compared to many other metals. There may exist some materials which are having larger elastic property than steel, but practically for manufacturing of those items, availability is less compared to the steel. So steel is used for construction of bridges and houses. For given beam, depression produced by a metallic beam when it is supported between two rigid supports, some weight is suspended through this. The depression delta produced equal to W by 4B y into L cube by D cube, where L is length of beam, D is this vertical dimension, B is this, W is the weight suspended, Y is its Young's modulus. So more is the Young's modulus, depression is less. Usually Young's modulus of steel is higher than other metals, so steel is used for that. So here both the statements are correct. We can go for option A. Next, 7th question. Solenoid having 70 turns per centimeter, current flowing in solenoid is 2 ampere. Find magnetic field inside the solenoid. It is a direct question, but only thing is it is given turns per centimeter, not meter. General expression for magnetic field inside the solenoid is mu naught Ni. We know that the value of mu naught is 4 pi into 10 power minus 7 SI units. Number of turns per unit length given is 70 by centimeter into current is 2 amperes. So in SI it can be written as 4 pi into 10 power minus 7 into 70 by 10 power minus 2 meter into 2, which is 8 pi into 70 into 10 power minus 5. 560 pi into 10 power minus 5 Tesla. It is given with option B. Power is missing here. It should be 10 power minus 5. Here it is given minus 4, but only 560 pi is there with B option. Next, 8th question. Separation between Earth and Sun is given by 1.5 into 10 power 6 kilometer. Time period of another planet is 2.83 year. Find distance of another planet from Sun. Suppose if it is position of Sun, this is any planet revolving with time period t at a distance r from center of Sun. According to Kepler's laws, we can write t square proportional to r cube. T2 by T1 whole square can be written as R2 by R1 whole cube. Here it is given T2 as 2.83 years, and we know that time period of Earth around the Sun is 1 year. So T2 by T1 will be 2. It is 2.83. 2.83 square is 8. Now R2 by R1 equal to 8 power 1 by 3. It is 2. So R2 equal to 2 times of R1. R1 given is 1.5 into 10 power 6 kilometers. So distance of that planet from center of Sun is 3 into 10 power 6 kilometers. It is given with option A. Next, question number 9. A photon is emitted from n equal to 4 to 1 level in hydrogen atom. The corresponding wavelength for this transfer will be, the value of Hc is given. We know that wavelength of emitted photon from hydrogen atom can be written as Hc by delta E, where delta E is energy difference between two states in which electron is jumping. So it can be written as 13.6 electron volt into 1 by n1 square minus 1 by n2 square. Here n1 equal to 1, n2 equal to 4. Substituting these values, it is 13.6 electron volt into 1 minus 1 by 16. It will be 13.6 eV into 15 by 16. Now the value of lambda, Hc given as 1240 nanometer electron volt by 13.6 electron volt into 15 by 16. So after calculations, it comes out to be 97.3 nanometer. It is given with option 4. 10th question. If all the particles have same kinetic energy, the relation between wavelength of alpha particle, electron and proton. Here is asking about de Broglie wavelength. De Broglie wavelength can be written as h by p, where p is momentum associated with the particle. We know that p square by 2m equal to kinetic energy. According to this, p equal to square root of 2 times of m into ke. Here it is given alpha particle, electron and proton. We know that mass of alpha particle is greater than mass of proton, which is greater than mass of electron. As lambda is inversely proportional to mass, is inversely proportional to square root of mass. It is clear lambda of electron is greater than that of proton, which is greater than that of alpha particle. It is given with option B. Next, 11th question. A rod of length L is rotating in uniform magnetic field as shown in figure, then induced EMF across its ends. This is the most standard and direct expression, B omega L square by 2, but we can prove this by taking a rod rotating about one of its ends, considering an element of length dx at a distance x from axis of rotation, whose speed can be written as x into omega, as it is rotating with angular velocity omega. EMF induced across the small element dx can be written as dE. General expression of motional EMF is LVB. Here L is nothing but length of the element, V is x omega, magnetic field B is constant here. So total EMF across the whole length of rod can be written as integral of omega B x dx. X square is from 0 to L, which comes out to be B omega L square by 2. Next, 12th question. When a parallel beam of white light incident on convex lens split into different colors, the phenomena is called. Suppose if I consider a parallel beam of light incident on a lens. See here, the refractive index offered by material of lens is different for different colors. According to Cauchy's relation, refractive index can be written as some constant A plus B by lambda square. In the spectrum of Vibgyor, violet has least wavelength, so refractive index offered for violet is more than that of red. More is the refractive index, more will be the deviation suffered by that. Thereby, violet light undergoes more deviation compared to the red light. So red light will form image farther away from the violet. This is image formed by violet light, it is image formed by red light. So image is not point, it is spreading across this length. This type of defect is called chromatic aberration, and this length is measure of longitudinal chromatic aberration. So here the correct option is B. Next, 13th question. Frequency can be represented as F equal to radius power A, density power B, surface tension power C. Find the values of ABC. It is based on dimensional analysis. Frequency can be written as inverse of time period. Radius can be written as length power A. Density can be written as mass by length cube power B, and surface tension S power C. Usually surface tension into length gives the force. Dimensional formula of force is ml T power minus 2. In this way, surface tension has dimensions of m into T power minus 2. So rewriting this, on left hand side it can be written as m power 0, L power 0, T power minus 1. On right hand side, L power A, m by, otherwise m into L power minus 3 power B. S can be m T power minus 2 power C. Equating the respective powers. First of all, let me rewrite it. L power A minus 3B, m power B plus C, T power minus 2C. Here it is m power 0, L power 0, T power minus 1. Equating the powers of T. Here it is minus 1, this is equal to minus 2C, which is giving C equal to 1 by 2. Next, equating the powers of L. 0 on left hand side equal to A minus 3B on the right hand side, which is giving A equal to 3B. Similarly, equating the powers of M. 0 equal to B plus C, which gives B equal to minus C, as C is 1 by 2, B equal to minus 1 by 2, A equal to 3 times of B, so it is minus 3 by 2. So now we got A equal to minus 3 by 2, B equal to minus 1 by 2, C equal to 1 by 2. So the corresponding option is given with B. Next, 14th question. If we move upward and downward from the surface of Earth, acceleration due to gravity decreases in both upward and downward directions. The first statement is correct. Acceleration due to gravity changes by same amount when we go up to height h and depth d when h equal to d. Let us see it. Suppose if I consider Earth as a sphere of radius r, if I consider a point P which is at a height h above the surface of Earth, assuming it is at a distance r from center of Earth, r equal to capital R plus h. Gravitational field at P can be written as Gm by R square form. It can be rewritten as Gm by R plus h whole square, taking capital R common. Gm by R square into 1 plus h by R whole square. Gm by R square is G naught. It is the value of acceleration due to gravity on the surface of Earth. Now for small values of h, by using binomial expansion, this can be written as, assuming this as G. So G equal to G naught into 1 minus 2h by R. Similarly, if point Q is at a depth d below the surface of Earth, which is at a distance r minus d from center of Earth. So gravitational field at Q can be written as Gm by R cube into R minus D. This is for an internal point of sphere. Let it be equation 1. Now for this, Gm by R square into 1 minus D by R. This is G naught into 1 minus D by R. This is equation 2. So it can be rewritten as G as a function of h above the surface of earth is g naught into 1 minus 2h by r. G as a function of d below the surface of earth is g naught into 1 minus d by r. If h equal to d, these two are not same, but both are less than g, means g naught, the value of g on the surface of earth. So here statement 1 is true, statement 2 is false. So correct option given with 2. 1 is true, 2 is false. Next, question number 15. A particle follows above Vt graph, then ratio of distance travelled and displacement of particle is given by. We know that displacement is area under curve in such a way that it is positive area minus negative area. On the other hand, distance is magnitudes of positive and negative areas. Suppose if I consider this part of area, it is 8 units on y-axis, 2 units on x-axis. So 8 cross 2, it is 16 units. So it is positive, so it should be positive for both distance and displacement. On the other hand, for this area, 2 units on x-axis, 4 units on y-axis. So total area of this is 8 units. For displacement, it should be subtracted. For distance, it should be added. Similarly, this part, total it is measuring 4 units on x-axis, 4 units on y-axis. Total area is 16. It is positive for both distance and displacement. Similarly, this part of area, it is also measuring 2 by 4, 8 units, negative for displacement, positive for distance. So it is 16 units, it is 48 units. Ratio of distance by displacement means magnitude of displacement by distance is 48 by 16, which comes out to be 3. Is asking displacement of ratio of distance travelled and displacement. So it should be 3:1. It is given with option A. Next, 16th question. A block of mass 200 gram is connected with a spring of spring constant 12.5 Newton per meter. It is rotating in horizontal plane with angular speed 5 radian per second. Find ratio of elongation in spring and natural length. Suppose let us consider a system of spring and block rotating in horizontal plane with angular velocity omega equal to 5 radian per second. Now length of string is L0 plus delta L, where delta L is elongation in the spring. The spring force here is providing the required centripetal force to the particle. Centripetal force is K delta L. But centripetal force can be written as m omega square r. R is distance of particle from axis of rotation. This is equal to K delta L. Can be written as m omega square. R is L0 plus delta L. This is equal to K delta L. Is asking the ratio of delta L to L0. Elongation in spring and natural length. Let us substitute the values. Mass given is 200 gram, means 0.2 kgs. Omega is 5, so omega square will be 25. L0 plus delta L. Force constant is 12.5 into delta L. So which is giving 5 L0 plus 5 delta L equal to 12.5 times of delta L. Rearranging it, 5 L0 equal to 7.5 times of delta L. 5 by 7.5 is delta L by L0, which is equal to 2 by 3. So it is given with option A. Next, 17th question. A solid cylinder of radius r and length L have moment of inertia I1, and second solid cylinder of radius r by 2, length L by 2, cut from it, have moment of inertia I2. Find I1 by I2. So here it is cut from the same cylinder, means we can write general expression for moment of inertia of a cylinder. If nothing is mentioned, we should assume the natural axis passing through center of mass perpendicular to plane of the flat surfaces are parallel to axis of the cylinder. For general expression, it is mr square by 2. As density of both the cylinders is same, we can eliminate m and rewrite in terms of density and radius. So it can be written as volume into density. Volume is pi r square L, density rho, into r square by 2. So moment of inertia is proportional to r power 4 and length L. He is asking I1 by I2. This can be written as R1 by R2 power 4 into L1 by L2. It is given that R2 is R by 2, means R1 by R2 is 2. So it is 2 power 4. Similarly, L1 by L2 is also 2. So it is 2 power 5, which is equivalent to 32. It is given with option B. Next, 18th question. Okay, this is first question of integer type. An electric circuit is given here, is asking to find reading of voltmeter. Here it is voltmeter of resistance 400 ohms. So first of all, let us find the effective resistance of this branch. Here 400 ohm is in parallel with 100 ohm. So effective resistance can be replaced here as is 90 volt cell, it is 100 ohm resistor. Let it be some R. R can be written as 400 into 100 by 400 plus 100, which comes out to be 80 ohms. If it is 80 ohms, total resistance of circuit is 180. So current flowing in the circuit can be written as I equal to 90 by 180 ohm. It is half ampere. If half ampere is the current, drop across 100 ohm resistor will be 50 volt. Remaining 40 volt drop will be appear across the voltmeter branch. So this is 40 volt. That is the reading given by the voltmeter. So finally the voltmeter reading is 40 volt. Next question. A dielectric of 3.5 is inserted and distance between plates is doubled. Find new capacitance if original capacitance was 7.5. Let us consider original capacitance of capacitor as C0, which can be written as epsilon naught A by D. Suppose this is the original capacitor. Separation between the plates D, area of each plate is A. Medium between the plates is air. Suppose if it is filled with dielectric material of constant K and separation is increased to 2D. There may exist two cases here. It is not clear from the question. After having separation 2D, if space is filled with dielectric, this is the situation. Let us assume C1 is the capacitance in this case. It can be written as K times of epsilon naught A by D prime. K given as 3.5, epsilon naught A by D prime is 2D. So it is 3.5 by 2 into epsilon naught A by D is C0, which is given as 7.5 picofarad. So it is 7 by 4 into 7.5 picofarad. So which comes out to be, if you calculate it, it is 105 by 8. It is 13.125 picofarad. So this is one possibility. Otherwise, there may be a chance of giving this situation here. It is filled in the original capacitor and after separation is increased to twice. Now D is thickness of dielectric material, 2D is the separation between the plates. In this case, capacitance can be written as general expression for partially filled dielectric parallel plate capacitor is epsilon naught A by D minus T plus T by K, where D is separation, here let it be D prime. T is thickness of dielectric, which is equal to D here. So it will be epsilon naught A by 2D minus D plus D by K, which is epsilon naught A by D plus D by K. So we can substitute the values and we can get the second possibility. So it seems it is first one or second one, exactly not clear. If it is the first case, we will get 13.125. For second case, we can substitute here and check. Next, third question. When ZX240 nucleus goes for fission, energy released is 200 mega electron volt. Total energy released when 120 gram of this sample undergoes fission is given 10 power 25 mega electron volts into some numerical value. We need to find that. See, when one nucleus undergoes fission, it is releasing an energy of 200 mega electron volt. Suppose n nuclei are undergoing fission, which releases n times of 200 mega electron volt. In 120 gram of sample, we need to find number of active nuclei of the given element. So number of active nuclei equal to number of moles into Avogadro's number. Number of moles is mass by molecular weight. Mass given is 120 gram, molecular weight 240 gram into Avogadro's number 6.02 into 10 power 23, which is equal to 1 by 2 into 6.02 into 10 power 23. So required energy equal to n times of delta E. N is roughly it is 3.01 into 10 power 23 into 200 mega electron volt. So it can be written as 6 into 10 power 25 mega electron volt. So here the required numerical value is 6. Fourth question. A wire is extended by 20%, keeping its volume is constant. Find the percentage change in its resistance. As 20% is very large value, we have to follow the direct method instead of using differentiation method. If percentage given is less than 5%, we can use the differentiation method, but here it is given 20. Means we need to find R2 minus R1 by R1 into 100. This is the percentage change in the resistance. First of all, it is given volume constant. So V1 equal to V2. Initial volume A1 into L1, final volume A2 into L2. It is said that L2 is L1 plus 20% of L1. So 0.2 L1. It is 1.2 times of L1. From this expression, A1 L1 equal to A2 into 1.2 times of L1. Means A2 equal to A1 by 1.2. Let it be equation 1. Now general expression for resistance is rho L by A, where rho is resistivity, L is length, A is cross section area. R2 can be written as rho into L2 by A2. L2 is 1.2 L1, A2 is A1 by 1.2. So it is finally 1.44 times of rho L1 by A1, means it is 1.44 times of R1. This is equation 2. Now percentage change in resistance delta R by R is R2 minus R1 minus 1 into 100, which is 1.44 minus 1 into 100, which is 44%. So here 44 is the answer. Next question. A lens of refractive index 1.5 and focal length 18 cm is in air is submerged in water. Change in focal length of lens is. When it is in air, its focal length is 18 cm. We need to find its focal length when it is in water. General expression for focal length in air is mu minus 1 into 1 by R1 minus 1 by R2, where mu is 1.5 minus 1 into, let it be some constant K. 1 by F naught value is 1 by 18 centimeter. It is 1 by 2 into K, which gives K equal to 1 by 9. Let it be equation 1. When it is immersed in medium of refractive index 4 by 3, its new focal length 1 by Fm equal to mu r minus 1 into the same constant K. Mu r is refractive index of material of lens by refractive index of medium. minus 1 into K. Means it is 3 by 2 by 4 by 3 minus 1 into K is 1 by 9 centimeters. So focal length in the liquid medium is, this is 9 by 8 minus 1 into 1 by 9, which is 1 by 8 into 1 by 9, it is 1 by 72. So focal length of lens in the medium is 72 centimeters. Now he is asking difference, F medium minus F air. 72 centimeter minus 18 centimeter, it is 54 centimeter. So required answer is 54. Next question. Two semicircular arcs of linear charge density, I think it may be lambda, are placed as shown in figure. Find the potential at O. Whenever a circular wire is given having some charge density lambda, potential at the center due to circular segment can be written as 1 by 4 pi epsilon naught times of Q by R, where R is its radius, Q is total charge. Because each and every elemental charge is at the same distance R from the center, and it is a scalar quantity. So simply we can write like this. Here there are two loops, loop of radius R1, loop of radius R2, two semicircular rings. So resultant potential is sum of, algebraic sum of potentials of both. This is 1 by 4 pi epsilon naught times Q1 by R1, similarly 1 by 4 pi epsilon naught times Q2 by R2. Q1 equal to lambda into length of the wire pi R1, Q2 equal to lambda into length of the wire pi R2. Substituting those values, 1 by 4 pi epsilon naught lambda pi R1 by R1 plus 1 by 4 pi epsilon naught lambda pi R2 by R2. So which is equal to lambda by 4 epsilon naught plus lambda by 4 epsilon naught, it is lambda by 2 epsilon naught. So something is missing here, it may be single option or numerical question, but answer is coming as lambda by 2 epsilon naught. It might have been asked in terms of lambda by epsilon naught. Next question. Ratio of molar heat capacity at constant pressure and constant volume for monoatomic and diatomic. Here also there is no clarity in the question. It seems it is asking specific heat capacities ratio of monoatomic gas to specific heat capacities of diatomic gas. So ratio of specific heats for monoatomic gas is 5 by 3, that for diatomic gas is 7 by 5. Now the ratio of gamma m by gamma d will be 5 by 3 by 7 by 5, which is 25 by 21, which is given with option A. Next question. Find current through battery after long time. These two inductors behave as conductors after long time, so they can be short circuited like this. After long time, effective circuit will be like this. It is 12 ohm resistor, 12 ohm resistor, 12 ohm resistor. It is 12 volt cell. So all are identical paths. So current through each branch will be 1 ampere. Here it is 1 ampere, here it is 1, here it is 1, because potential difference across each element is 12 volts. Total current flowing through battery will be 3 amperes. So required answer for this is 3. So we are able to identify only this much number of questions. Thank you.